Good morning, everyone. This is Dr. Hanuman Prasad Pandiri, an associate professor at MREC Autonomous. In this session, I am going to discuss alkalinity of water and various relations between partial as well as total alkalinity. Here I am going to discuss three contents. First one, concept of alkalinity. Second one, indicators for titration of alkaline water. Third one, possible combinations of ions causing alkalinity. The first one, concept of alkalinity. The alkalinity of water is mainly due to three ions: hydroxide, carbonate, and bicarbonate. Hydroxide ion is represented as OH minus, carbonate ion is represented as CO3 2 minus, and bicarbonate ion is represented as HCO3 minus. The alkalinity due to first two ions, that is hydroxide and carbonate, is considered as caustic alkalinity, and the alkalinity due to third ion, that is bicarbonate, HCO3 minus, is considered as alkalinity due to temporary hardness. So these three ions cause alkalinity of water: OH minus, CO3 2 minus, and HCO3 minus. The second content is various indicators for the titration of alkaline water. First of all, the given water sample has to be titrated with an acid solution, let's say standard sulfuric acid solution, using two indicators. One is phenolphthalein and the second one is methyl orange. If the given water sample is titrated against standard acid solution up to phenolphthalein endpoint. Here phenolphthalein endpoint is nothing but the endpoint using phenolphthalein indicator. In this case, the total amount of acid used represents phenolphthalein alkalinity or partial alkalinity. This is denoted by P. And if the given water sample is titrated against standard acid solution up to methyl orange endpoint, that is the endpoint observed using methyl orange indicator, then the total amount of acid used represents methyl orange alkalinity or total alkalinity. It is denoted by M or T. If you see the reactions involved in the case of partial alkalinity or phenolphthalein alkalinity are OH minus plus H plus gives rise to H2O. That means OH minus will be completely titrated and CO3 2 minus plus H plus gives rise to HCO3 minus. That means carbonate is half titrated. So phenolphthalein alkalinity P can be formulated as P equal to OH minus concentration plus half CO3 2 minus concentration, because OH minus is completely titrated and CO3 2 minus is half titrated using phenolphthalein indicator. And by using methyl orange indicator, all the three ions, that means OH minus, CO3 2 minus, and HCO3 minus will be completely titrated. That is, the three reactions are involved if you use methyl orange indicator. So M can be formulated as M equal to OH minus concentration plus CO3 2 minus concentration plus HCO3 minus concentration. So by using these relations, we can design possible combinations of ions causing alkalinity. That is our third content. So if you titrate the given water sample using phenolphthalein indicator, you will get phenolphthalein alkalinity, which is denoted by P. And if you titrate the given water sample using methyl orange indicator, you will get methyl orange alkalinity or total alkalinity denoted by M. As I discussed in the earlier slides, P is formulated as OH minus concentration plus half CO3 2 minus concentration. And M is formulated as M equal to OH minus concentration plus CO3 2 minus concentration plus HCO3 minus concentration. Now, in the titration, if you observe P equal to 0, that is, the relation between P and M can be P equal to 0. So this is the first relation. If P equal to 0, then we can substitute it in the formula of P, that is OH minus concentration plus half CO3 2 minus concentration will be 0. If it is 0, which indicates OH minus concentration is 0 as well as CO3 2 minus concentration is also 0, then only P will be 0. That means the first case or the first relation P equal to 0 is valid only when OH minus concentration as well as CO3 2 minus concentration are 0. Then M will become, M means methyl orange alkalinity, will be, here OH minus concentration is 0 and carbonate concentration is also 0. Then M is equal to HCO3 minus concentration. So the concentration of HCO3 minus will become M. So if P equal to 0, the concentrations of 3 ions, OH minus concentration is 0, CO3 2 minus concentration is also 0, and HCO3 minus concentration is M. So this is about the first relation, that is P equal to 0. And in the titration, if you observe P equal to half M, that means phenolphthalein alkalinity is exactly half of methyl orange alkalinity. This relation will be valid only when OH minus concentration is 0 as well as bicarbonate concentration is also 0. Let's substitute these two values in the P and M. So P will become half CO3 2 minus concentration because OH minus concentration is 0, and M will become CO3 2 minus concentration. That's all, because HCO3 minus concentration is also 0. So in this case, P equal to half carbonate concentration and M equal to carbonate concentration. So P will be exactly equal to half M. Now, as I discussed already, OH minus concentration is 0 and bicarbonate concentration is 0 if P equal to half M. Now, the only ion responsible for alkalinity of water is carbonate, CO3 2 minus. And its concentration can be calculated using expressions of P and M. As I told, P equal to half into CO3 2 minus concentration. Then you will get CO3 2 minus concentration equal to 2P. And M equal to CO3 2 minus concentration. That means CO3 2 minus concentration is M. So CO3 2 minus concentration is either 2P or M. If you observe, phenolphthalein alkalinity is exactly half of the methyl orange alkalinity. And now let's go to third relation. In the titration, if you observe, phenolphthalein alkalinity is greater than half of methyl orange alkalinity. That is, P is greater than half M. This relation is valid only when bicarbonate concentration is 0. So let's substitute bicarbonate concentration as 0. P will become hydroxide concentration plus half carbonate concentration. And M will become hydroxide concentration plus carbonate concentration because bicarbonate concentration is 0. Now, if you observe carefully, half M will be half OH minus concentration plus half carbonate concentration. Now, P is greater than half M because P has full OH minus concentration and half M has only half OH minus concentration. You know that full OH minus concentration is higher than half OH minus concentration. So the relation will be P is greater than half M. So as I told here, bicarbonate concentration is 0 and we can derive OH minus concentration as well as CO3 2 minus concentration by adding and subtracting P and M. So in this case, OH minus concentration will become 2P minus M and carbonate concentration will become 2M minus 2P, that is 2 into M minus P. Okay, so this is about third relation, that is P greater than half M. And in the titration, you may observe P less than half M. That means phenolphthalein alkalinity is less than half of methyl orange alkalinity. In this case, the OH minus concentration should be 0. Then only this relation is valid. P is less than half M only when OH minus concentration is 0. Let's substitute OH minus concentration as 0 in both P and M. So P will become half CO3 2 minus concentration and M will become CO3 2 minus concentration plus HCO3 minus concentration. Now it is clear that P is less than half M because half M will become half CO3 2 minus concentration plus half HCO3 minus concentration. But P is only half CO3 2 minus concentration. Since half M has an excess of half HCO3 minus concentration, here P is less than half M. As I told in this relation, OH minus concentration is 0. And now you can derive the concentrations of carbonate as well as bicarbonate by adding and subtracting P and M. So you will get carbonate concentration is equal to 2P and bicarbonate concentration is equal to M minus 2P. So these are the concentrations of the three ions OH minus, CO3 2 minus and HCO3 minus. In the case of P is less than half M. This is the fourth relation we discussed. And now there may be another possibility in the titration, P equal to M. This relation is valid only when carbonate concentration as well as bicarbonate concentrations are 0. Let's substitute these two as 0 in P and M. So P will become OH minus concentration because carbonate concentration is 0. And M also will become OH minus concentration because carbonate concentration as well as bicarbonate concentrations are 0. So P equal to OH minus concentration and M is also equal to OH minus concentration. So it is clear that P equal to M. So in this case, carbonate concentration and bicarbonate concentrations are 0. And the only ion that is responsible for OH minus responsible for alkalinity of water is OH minus. And its concentration is either M or P. So in overall, the alkalinity of water is due to three ions: hydroxide, represented as OH minus, carbonate, represented as CO32 minus, and bicarbonate, represented as HCO3 minus. And the titration of alkaline water sample can be done using standard acid solution, let's say standard sulfuric acid solution, by using phenolphthalein indicator to get partial alkalinity or phenolphthalein alkalinity, where OH minus will be titrated completely and CO32 minus can be titrated only to half extent. So P is formulated as OH minus concentration plus half of CO32 minus concentration. And the given water sample can be titrated using standard acid solution with methyl orange indicator. In this case, you will get methyl orange alkalinity or total alkalinity. Here, OH minus will be completely titrated and CO32 minus will be completely titrated, as well as HCO3 minus will also completely titrated. That means M is equal to OH minus concentration plus CO32 minus concentration plus HCO3 minus concentration. And the five relations between P and M that we have discussed are: P equal to 0. This is possible if OH minus concentration is 0, CO32 minus concentration is 0, and HCO3 minus concentration is M. That means if P equal to 0, the one and only ion responsible for alkalinity of water is bicarbonate, HCO3 minus, and its concentration is M. And the second relation we discussed is P equal to half M. Here, OH minus concentration is 0 as well as HCO3 minus concentration is 0. And CO32 minus concentration is either 2P or M. So, if P equal to half M, the one and only ion responsible for alkalinity of water is carbonate, CO3 2 minus. And its concentration is either 2P or M. And the third relation that we can observe is P is greater than half M. This is valid only when HCO3 minus concentration is 0 and OH minus concentration is 2P minus M and CO32 minus concentration is 2 into M minus P. That means if P is greater than half M, the ions responsible for alkalinity of water are hydroxide as well as carbonate. And hydroxide concentration is 2P minus M and carbonate concentration is 2 into M minus P. And the fourth relation that we can observe is P is less than half M. Here OH minus concentration is 0, carbonate concentration is 2P and bicarbonate concentration is M minus 2P. That means if P is less than half M, the ions responsible for alkalinity of water are carbonate as well as bicarbonate. And the concentration of carbonate is 2P and concentration of bicarbonate is M minus 2P. This is the fourth relation. And the fifth relation that we can observe is P equal to M. That means phenolphthalein alkalinity is equal to methyl orange alkalinity. Here OH minus concentration is either M or P, CO32 minus concentration is 0 and HCO3 minus concentration is also 0. That means the relation P equal to M is possible only when CO32 minus, that means carbonate ion, is responsible for alkalinity of water. Sorry, OH minus is responsible for alkalinity of water and the rest of two are not responsible. Means if the given alkaline water sample contains only OH minus ion, then you will observe P equal to M. And the concentration of OH minus is either M or P. So as we discussed, these 5 relations, P equal to 0 is observed, and the only ion responsible for alkalinity of water is bicarbonate, and its concentration is M. And P equal to half M, here the only ion responsible for alkalinity of water is carbonate, and its concentration is either 2P or M. And P is greater than half M, here the ions responsible for alkalinity of water are hydroxide and carbonate. OH minus concentration is 2P minus M, carbonate concentration is 2 into M minus P. And the fourth relation is P is less than half M. Here the ions responsible for alkalinity of water are carbonate and bicarbonate, and carbonate concentration is 2P and bicarbonate concentration is M minus 2P. And the fifth relation is P equal to M. Here the only ion responsible for alkalinity of water is OH minus, and its concentration is either M or P. So that is how we can determine which ions are responsible for alkalinity of water by titrating the given water sample with standard acid solution, that is standard sulfuric acid solution. If you observe P equal to 0, the only ion responsible for alkalinity of water is HCO3 minus. If you observe P equal to half M, the only ion responsible for alkalinity of water is carbonate. If you observe P is greater than half M, 2 ions are responsible for alkalinity of water, which are OH minus and CO3 2 minus. And if P is less than half M, 2 ions are responsible for alkalinity of water, which are CO3 2 minus and HCO3 minus. And if P equal to M, only OH minus ion is responsible for alkalinity of water, and its concentration is either M or P. Thank you for your patient listening. All the very best.